Few days ago, Google announced ScreenAI. ScreenAI is a vision language model developed by Google AI that can comprehend both user interfaces and infographics. It is capable of tasks like graphical question answering, element annotation, summarization, navigation, and also user interface specific question answering. This new research is based on PaLI. PaLI stands for Pathways Language and Image Model. PaLI is a model that extends this approach to the joint modeling of language and vision. PaLI generates text based on visual and textual inputs, and with this interface performs many vision language and multimodal tasks in many languages. Screen AI's architecture is based on this PaLI, which is composed of a multimodal encoder block and an autoregressive decoder. The PaLI encoder uses a vision transformer or VIT that creates image embeddings and a multimodal encoder that takes the concatenation of the image and text embeddings as input. This flexible architecture allows Screen AI to solve vision tasks that can be recast as text image to text problems. On top of PaLI architecture, they have employed a flexible patching strategy introduced in Pix to instruct. Instead of using a fixed grid patterns, the grid dimensions are selected such that they preserve the native aspect ratio of input image. This enables Screen AI to work well across images of various aspect ratios. The Screen AI model is trained in two stages. First one is a pre-training stage followed by a fine-tuning stage. First, self-supervised learning is applied to automatically generate data labels which are then used to train WIT and the language models. WIT is frozen during the fine-tuning stage where most data used is manually labeled by human raters. This is the architecture which they have used thoroughly. Now, if you look at it, what is happening here is this is a block diagram of their workflow for generating data for question answering, summarization, and navigation tasks using existing Screen AI models and LLMs. Each task uses a custom prompt to emphasize desired aspects like questions related to counting, involving reasoning, and so on and so forth. And this is one of the examples where they are doing this sort of question answering, which you can see is quite interesting in terms of how this workflow happens. LLM generated data is really coinciding with your screenshots. So this is the screen question answering, and you can also do navigation and summarization. For navigation, the action bounding box is displayed in red on the screenshot as you can see here. So as I mentioned earlier, Screen AI is trained in two stages, pre-training and fine-tuning. Pre-training data labels are obtained using self-supervised learning and fine-tuning data labels come from human raters. They fine-tune Screen AI using public question answers, summarization and navigation datasets and a variety of tasks related to user interface, which is quite of high quality. For instance, if you look at this screen, this is a mobile app screenshot with generated annotations that include user elements and their descriptions. For example, text elements also contain the text content from OCR, image elements contain image captions, and list underscore items contain all their child elements. To create a pre-training data set for Screen AI, they have first compiled an extensive collection of screenshots from various devices, including desktops, mobile, and tablets. This is achieved by using publicly accessible web pages and following the programmatic exploration approach used for Rico dataset for mobile apps. And then they applied a layout annotator based on data model that identifies and labels a wide range of UI elements and their spatial relationships. They have also used pictograms and a lot of other things, which I will drop the link of this paper in video's description, and then you can read further along as it is quite a good read. And for instance, you can just simply provide it a screenshot and ask it to summarize that screenshot as you can see on your screen. All we have done is we have just given it a input prompt, summarize the screenshot, and it has gone through and given us the summary of what is happening in this screenshot. And in another example, you can see that uh, Here all we are doing it, we are just giving it a natural language instruction, and it is converting into an executable action on the screen. For example, here the text input is select the first item on the list, and it has selected it. You can ask it to scroll down, scroll up, click here and there. So not only it is deciphering the screenshot, but you can also control the screen with it. So you can see that this is going to be huge very soon, and Google is really making quite an inroad there. So let's wait for this model to get released, and then we will maybe try a demo or try to get it installed locally. I will drop the link to its project page in the video's description. Go through it, let me know what do you think. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.